usually the lungs are much bigger than this. Like they're usually like this big, but for some reason the lungs are very small this year. So brace yourself. So that one's a bit bigger. We'll use that one. Which one is bigger? That one. Yes. Yeah. So this is a cow lung. Bovine means cow. Looks like there's some holes in it, unfortunately, so probably have to use a different one. But you guys can see what structure is this, guys? The trachea. And you can see the C-shaped rings that go all the way around. Very exciting. You can see they don't connect in the back, and this allows some flexibility, so it allows the cow to move its head around. It also allows flexibility for another structure that is normally right here. What structure is that? The esophagus, yes. So when the esophagus expands and contracts when it's undergoing peristalsis to push the food down the esophagus, there has to be a little bit of room here for the trachea to expand, or else there would be a lot of friction against the trachea, and we don't want friction in the human body. So if we lay it out, looks like this one's like been cut as well too. Oh no, that's okay. Okay, so this half of the lungs here, we have one lobe, and then our second lobe is here. You can kind of see like this connective line here. If you guys want to look, you can see there's like a line kind of separating them. So the two lobes are kind of held together by the pleural membrane, but we have one lobe, two lobes here, and then we have 1, 2, and 3 lobes on this side. So which one is the left side? Yes, this one, the one with the 2. And so we can kind of see that there's an extra space here. This lung is kind of falling apart a little bit, it looks like. But you can see like this has a little bit of a bend here, and this one doesn't. This one just goes straight down. So what normally goes right here in the body? The heart. And do you remember what this part is called? The cardiac notch, yes. So the cardiac notch is there to make space for the beating of the heart and the expansion of the lungs. I don't know if these ones are going to inflate. There's like a big hole here. Yep, that is the bronchus. Okay, so if we have the trachea splits into 2, and you can see right here, oh, this is already open at the back, so we can actually look and see. You can see one bronchus here. You can see that hole there. So actually come in here, like tilt your head over it, guys. So you can see this hole here, this is one bronchus. The other bronchus is no longer attached, but if we look down this pathway here, you can see that bronchus splitting into bronchioles. So there's a bunch of little holes right there. You guys can see that. Little holes right there. And those are the bronchioles. You'll have to get a different one to inflate. You can also see the inside, it's pretty smooth, and there's connective tissue holding the cartilaginous rings together. So that split into bronchioles, we can see. So if you want to poke the lungs, come over and feel them. Just poke them. Just 2?
Oh, it's so squishy. Yeah, guys, like, come on. Why is no one poking the lungs?
Just 2. All right, there's gloves here.
Oh my god, I didn't think it'd be that squishy.
And then if you want to feel here, like just poke here, these are the bronchioles.
Oh, yeah.
That's the spot. So you can feel that it's like kind of crunchy, guys.
Yeah.
Yeah, it is kind of crunchy if you like press on it.
Yeah, you can feel kind of like the bulges in it.
Yeah.
Oh, what the hell? Oh, what? Oh my, it's so squishy. I know. I don't like it. Yes.
Okay. And let's see, sometimes I can get out bronchioles, sometimes I can't. You can kind of see one of the bronchioles here. Let's see if I can get some of it out more. These scalpels are not good. I don't know how you guys do anything with them. Okay, there we go. So you can kind of see how the tube, you have to come in a bit close. You can kind of see the tube there, so we can see that the bronchus spritz into the bronchioles, and then the bronchioles are like immersed in the lung tissue there. So if you want to come see that, I'm not going to pick up the lungs and splash you guys. So.
That'll be pretty funny.
Go. Yeah, please don't. I think they would hold up for that. So the sacs that make up this section of the lungs, what are these called? Little air sacs. Alveoli, yes. So alveoli is plural. What's singular? Alveolus, yes. So the trachea branches into the bronchus, or the trachea turns to the bronchus, and the bronchus branches into little bronchioles. And then those get smaller and smaller and smaller until they end in kind of like bundles of grape structures, like the alveoli. And then the pleural membrane is what holds all these sections together. When we inflate the lungs, you'll be able to kind of see that the lungs are actually sections, like they're not solid pieces, and those are the little bundles of the alveoli. This part here, this is just like connective tissue holding it together. Yeah, we usually get them like more intact than this. Like there shouldn't be a big hole here. So I'm just gonna see if, I might have to use the one we already used in block 1. Did I keep it over there? No, I threw it away. Is this one intact? Sorry. All right, let's try. I'll put the tube in there and see what happens. So I need someone to be the person who presses the air gun.
I can do it.
You don't have to touch the lungs. You want to do it? Okay, yeah. Do you want to give someone your phone? I don't know if this is going to work. Oh yeah, of course. So put some gloves on.
The window's right there. The door's right there.
We can probably inflate at least one of them. So normally this is intact. It's not this time, unfortunately. So I'm going to insert this into this part here, and then when I say go, you're going to put this in there as far as it will go, and then you're going to hold the seal shut with your hands, and then you're going to turn the air gun on. Okay? All right. There's like nobody for me to grab onto. All right, let's try this and see if it goes. So go ahead. So come close to lungs. I'm gonna re-inflate it. If we do it a couple times, it actually inflates better.
Look at the color change.
Okay, so let's do it again. I'm just gonna shove it in a bit more. It's not gonna explode, don't worry. Okay, you can open there. 1, 2, 3. You can see this other lobe is inflating. There you go.
So squishy.
So just notice the size difference between the deflated and inflated lung. The size, once we have the actual air in. And this part over here, that's the lung too. That's the right lobe. Okay, we get some. Okay, so when we are breathing, which is the big muscle that contracts and pulls down? The diaphragm. So the large muscle that contracts and pulls down, the diaphragm works with the intercostal muscles. So the intercostal muscles are the ones in your ribs, move up and out, your diaphragm pulls down. Because the thoracic cavity is a sealed cavity, it creates a negative pressure in it. So it sucks air into the lungs. So when you're exhaling, all your diaphragm has to do is relax. It doesn't have to actively exhale. So unless you're like physically pushing out the air in your lungs, all you have to do is relax. And we can kind of see that when we pull the air, the tube out of the lungs, they immediately deflate. I don't have to press the lungs to get the air out. So the alveoli are just stretched now. That's why they're like a different color, but they're just gonna keep that consistency. Does anyone else want to be the gun presser? All right, come on over here. I would keep it on to hold the seal. So hold that one, there you go. So I want you guys to watch, so look at the size it is now. So remember that inhalation is an active process and exhalation is a passive process. All we have to do is relax all of the muscles. And you can see that here, all of a sudden we'll stop the gun when I say stop, and you'll see the air moves out by itself, okay? So that's what you guys are looking for. Let's see if we can put that in there. All right, in 3, 2, 1, go. You can see it inflating and stop the gun. There you go. Thank you. That happened in block 1 as well. So we can see these lungs are a bit damaged because normally like this would inflate as well. Maybe I can get this one to inflate all the way. Alrighty. All right, let's go in 3, 2, 1. Oh my God. There we go. We can see 1 lobe and 2 lobes. So that's how we know it's the left-hand side. And you can see that the lungs are quite durable, so if I pierce them, it doesn't deflate the lungs. Thank you very much. Thank you for your help. So, because the alveoli are separate sacs, even if I were to pierce the lung, it doesn't deflate. The only way it deflates in the body is if we break that negative pressure when we're sucking in. So if the pleural membrane suction is broken, but if the alveoli is burst for some reason, it would be fine except for that one area of alveoli. So when our diaphragm contracts and pulls down, we create negative pressure, which pulls air into the lungs. When your diaphragm relaxes, it increases the pressure. It's a positive pressure and it pushes the air out of the lungs. So you don't have to do anything, you just have to kind of, your body waits for that difference in pressure. So negative in, positive out. So that means we're decreasing the pressure when we're breathing in because it's getting more negative. The number is getting lower, and we're increasing the pressure when we breathe out because we're kind of not forcibly pushing it out, but it's a positive pressure, pushing that air out of the lungs. And you can feel it now. It feels really like, this is what I was talking about with the butter slime. And if you kind of like push it in, you're cracking some of the alveoli, so it kind of crackles.
Ooh. Oh, wait, it's kind of satisfying.
Oh my God.
It like sizzles.
It does.
It's such a weird feeling.
Yeah.
But yeah, we couldn't get this guy to inflate, unfortunately. So this is a bunch of little tiny air sacs when we inflate it. One of the questions on your lab to answer is, if we were to put the lungs in water, would they sink or would they float? So I want you to I'm gonna cut off a piece of the lung and talk to the person next to you, make a prediction. I'm gonna drop it into the beaker. Do you think a piece of this will sink or float? Okay?
It's floating.
Yeah, what is that?
It's floating. It's water. It's water. It's water. What's water?
Oh, yeah, if it's water.
Okay, Ellen, ready? So this is the piece that's dropping in there. It's very light because it's not dense at all.
That's all.
3, 2, 1. Wow! It wasn't a trick question. So logically, we can predict that the piece of lung will float because we know it's filled with tiny air bubbles. It's like if you put a big bundle of balloons in water, we know that they're going to float because it's just a bunch of air, and air is less dense than water, so it floats. In block 1, someone asked, could we burst the lungs if we had with the gun? No, the gun is not powerful enough. Like, you need a lot of pressure to burst your lungs, a lot of pressure to burst these lungs, although some people's lungs are more sensitive than others. You guys know that if you inhale helium, you can make your voice higher. So some people take helium balloons and they inhale them just a little bit at a time, and it changes the atmospheric pressure in your larynx. So it decreases it, so it makes the vocal cords vibrate faster, which is why your voice can get so much higher. But what can also happen is if your lungs are not as strong as you expect them to be, if you let too much of that air go into your mouth, you can burst one of your lungs. So just be careful doing that. Some people will take a lot of pressure, some people can take a balloon emptying too quickly into your lungs. So just be careful when you're doing things like that. Any questions? Nope. These lungs are pretty healthy. Sometimes we get lungs that are like a black or browny color. Those are like damaged alveoli, and there's like buildup of different chemicals in there. These ones are a nice bright pink color, so there's no extra buildup. The alveoli themselves are pink, so we have that nice color. So if we were to take a smoker's lungs, they wouldn't inflate as well, and they would be covered in like brown and black from the tar buildup over the years. So. And vaping as well, so it's not a good choice. That bubblegum flavor is not worth it. Yeah. One thing that happens with vaping is it can line the inner alveoli with a layer of cobalt. Do you guys know what cobalt is?
Yeah.
An element on the periodic table. It's a heavy metal. What do you think happens to gas exchange if you line your alveoli with a layer of metal? Talk to the person next to you. What do you think?
Oxygen poisoning?
No, the thing will be oxidized because like you get oxygen, right?
Oh yeah.
Yeah, and then they will just say they're electricity.
So the cow is not vaping. Oh, yeah.
Nah, you
Any
do more
guesses?
push-ups.
Any guesses?
Actually, we should
What do you
probably-
think happens to gas exchange
Gas exchange.
when we line our lungs with things like tar or different chemicals or cobalt? What do you think happens?
It exchanges with the
Do you think it gets better?
no. It's worse.
No, it gets worse. We're adding an extra layer that they have to diffuse from. And these alveoli are also super flexible as well. You saw the change in size, and that's because of the lipoprotein secretion and just like the healthy proteins of the alveoli. But when we add extra chemicals in there, we can make them less flexible so they don't expand as well. So they don't take in as much air, and gas exchange is reduced because you need a moist surface, and when they get less flexible, they hold on to the lipoprotein less, or the surfactant less well, and so we have decreased diffusion of gases as well. So putting stuff in your lungs is bad, in summary. Any questions? This one's pretty fast. Okay, maybe share your pictures around if you were a picture taker, and yeah, that's it for today. So go ahead, work on your dissection, work on the review's been posted on the OneNote.